Welcome back, dear dreamer. Tonight we drift into the silent depths of the cosmos, where black holes rest like quiet anchors in the fabric of space. They are not creatures of noise or fury. They move with the slow certainty of gravity itself, shaping time and light with a calm, steady pull. Most wonders of the universe shine or roar, but black holes exist in a deeper stillness, as if they have learned the art of simply being. As you listen, let your breath soften, and let your thoughts drift like stardust settling through a weightless sky. This is not a journey of fear or mystery. It is a gentle walk through gravity's cradle, through patience, balance, and the quiet strength that holds galaxies together. Settle in, get comfortable, and let the night carry you through the soft curves of space-time. And if these peaceful cosmic journeys bring you comfort, remember to subscribe and tap the like button. Now, let us begin. Black holes often sound frightening, but when you look at them through a calm and scientific lens, they become something almost peaceful, like quiet anchors in the universe that reshape the flow of space itself. A black hole begins when a massive star collapses under its own weight, and instead of exploding outward, it folds inward, pulling space-time with it. The gravity grows so strong that not even light can escape. What makes this soothing rather than scary is that a black hole doesn't chase or hunt anything. It simply sits in silence, shaping the space around it with invisible curves, like a heavy stone resting at the bottom of a still pond. Scientists like Carl Schwarzschild gave us the first mathematical description of this strange object, showing how gravity can bend reality itself. Thinking about this gentle reshaping of space-time can feel like watching ripples fade into calm water. A black hole bends time as well as space, and the effect is so subtle and steady that imagining it feels like watching a slow sunset. Time moves differently near the event horizon, the invisible border where escape becomes impossible. If you floated safely far away, you would see clocks near the black hole ticking at a slower pace, stretched gently by gravity. Einstein predicted this in his theory of general relativity, which showed that time is not fixed, but can stretch and soften depending on gravity's pull. This doesn't feel violent. It feels like the universe adjusting its rhythm, letting moments lengthen the closer you move toward intense gravitational fields. Even astronauts traveling near a black hole, if that were possible, would return slightly younger than those who stayed away. Thinking about time behaving like a quiet river, slower in some places, faster in others, can be strangely comforting, as if the universe itself knows how to relax. Scientists often describe black holes as one-way doors, but even that idea can be calming when explained softly. If light or matter crosses the event horizon, it doesn't feel a sudden shock or barrier. Instead, it drifts inward as if following a gentle slope. The outside universe, however, will never see it return. This concept helps us understand how gravity behaves at extremes, offering clues about how the universe works at its deepest levels. Stephen Hawking studied this behavior for decades, showing that black holes slowly evaporate by releasing tiny amounts of radiation, now called Hawking radiation. This means a black hole isn't eternal. It fades gradually over unimaginable spans of time. It's a reminder that even the most powerful objects in the cosmos follow natural cycles of change. Imagining these quiet, slow processes can feel like watching mountains erode or glaciers drift, huge forces working in silence over billions of years. At the center of a black hole lies something called a singularity, a place where gravity becomes so strong that our current physics can't fully describe it. Instead of picturing something violent, think of it as a quiet point where the equations become soft and uncertain, where space-time folds into a region beyond our understanding. Kip Thorne and other physicists describe this not as chaos, but as a sign that the universe still holds mysteries waiting to be uncovered. The singularity is hidden behind the event horizon, completely sealed away from the rest of the universe, so nothing outside ever interacts with it directly. This keeps the mystery tucked safely out of reach, like a sealed book that no one can open, but everyone can wonder about. In bedtime thinking, this unknown center feels less like a threat and more like a peaceful invitation to curiosity, showing that even the universe carries secrets quietly. Black holes can spin, and a spinning black hole feels like a cosmic whirlpool, turning slowly but powerfully enough to twist space-time itself. These rotating black holes are called Kerr black holes, named after Roy Kerr, who solved the equations describing them. The faster a black hole spins, the more it flattens slightly at the poles and forms a region around it called the ergosphere. Inside the ergosphere, space-time is dragged along in a smooth swirl. Nothing inside can remain still. Everything is gently pulled along by the rotation. But this movement isn't harsh or chaotic. It's consistent, predictable, and rhythmic, almost like a slow cosmic dance. Imagining space-time curving and twisting around a spinning black hole can feel like watching a silent spiral of fog. The physics behind it may be complex, but the image of a smooth gravitational whirl can be surprisingly relaxing when you think of it as the universe moving in graceful patterns. In the center of many galaxies, including our own Milky Way, there sits a supermassive black hole, millions of times heavier than the Sun. Ours is called Sagittarius AA, a calm giant hidden behind clouds of dust and glowing gas. Despite its size, it doesn't swallow everything around it. Instead, it helps stabilize the galaxy, holding stars in long, graceful orbits that take millions of years to complete. Observations from the European Southern Observatory revealed stars whipping around it at incredible speeds, yet the motion remains smooth and predictable. Thinking of the entire galaxy turning slowly around this invisible anchor feels peaceful, like watching a mobile rotate in a child's room. The black hole is silent, steady, and patient. It has existed for billions of years, shaping the heart of our galaxy without noise or rush. Imagining this quiet giant gives the universe a sense of order and calm. Not all black holes are huge. Some are tiny, formed from stars just a few times heavier than our Sun. These smaller black holes are called stellar mass black holes, and they exist scattered across galaxies like faint whispers of collapsed stars. When these stars reach the end of their life cycle, they collapse inward and create a compact object with an incredibly strong pull. But afterward, the black hole remains quiet, drifting through space without emitting light. They can only be detected by the way they influence nearby stars or gas, making them feel like hidden pockets of gravity. Scientists have detected them by watching stars wobble gently, revealing the presence of an unseen companion. These small black holes remind us that the universe contains both grand and subtle features. Thinking about these invisible objects drifting silently through the galaxy feels like imagining smooth stones resting under calm water. Black holes sometimes form pairs, orbiting around each other in a slow, powerful embrace. These binary black holes swirl closer and closer over millions of years, releasing gravitational waves as they dance inward. The waves spread through the universe like faint ripples on a cosmic pond. Einstein predicted these ripples, and in 2015, the LIGO Observatory finally detected them, confirming one of his deepest ideas. The merger of two black holes is a dramatic event, but from a distance, the idea feels serene. Two massive objects spiraling together in silence, sending gentle distortions across space-time. These waves pass through everything, stretching and contracting space so subtly that we cannot feel it. Imagining this quiet, rhythmic motion is calming, like listening to distant, slow breaths of the universe. The thought that space-time can carry such soft waves reminds us how even colossal events unfold in elegant, gentle patterns. Space around a black hole is not empty. Gas, dust, and light swirl around it in beautiful patterns, forming something called an accretion disk. The gas in this disk heats up as it spirals inward, glowing softly with energy. When imagined from afar, the disk looks like a thin, shining halo surrounding a dark center. The movement inside the disk is fast but smooth, a continuous circular flow shaped by gravity. Telescopes like the Event Horizon Telescope gave us the first image of such a disk around a supermassive black hole in the galaxy M87. The image showed a warm, glowing ring framing a shadow, almost like a candle burning around darkness. Thinking about this quiet glow in space can feel comforting, like watching a warm light flicker in a room at night. The accretion disk reminds us that even extreme environments can produce beauty. Some black holes emit jets of energy that shoot out from their poles, stretching thousands of light years into space. These jets are not made of material coming from inside the black hole, but from the energy of magnetic fields swirling around the accretion disk. When imagined gently, the jets look like thin beams of light flowing out in straight lines, almost like glowing threads in the night sky. Though the process behind them is energetic and powerful, the image itself carries a kind of stillness. The jets remain steady for millions of years, pointing in the same direction, like calm cosmic lighthouses. Scientists study these jets to understand how energy escapes the regions around black holes. Their consistency and shape remind us that even in the universe's most extreme places, there are stable patterns and long-lasting structures that feel peaceful when seen from far away. Black holes don't always stay still. Some drift through galaxies, moving slowly like wandering travelers in the night. After two galaxies merge, their central black holes can be pushed off-center or even flung away by gravitational interactions. These roaming black holes carry their invisible pull with them as they move. They don't shine, so they glide silently, passing through stars and gas without disturbing most of what they encounter. Astronomers predict many such wandering black holes exist in the Milky Way, drifting far from view. The idea of these quiet travelers can feel peaceful, like watching a dark cloud glide across a calm sky. They remind us that motion in the universe doesn't need to be fast or loud. Sometimes, the most massive objects move with slow patience, showing that even the greatest forces can exist in steady, gentle motion. When matter falls into a black hole, it never disappears from the universe in a simple way. Instead, its information becomes tangled with the black hole itself. This led to the famous information paradox, a puzzle that fascinated Stephen Hawking and many others. While the physics behind it is complex, the idea itself has a soothing side. The universe never loses track of anything completely, even if the details become hidden. Hawking proposed that information might slowly escape through radiation as the black hole evaporates. This means nothing is truly gone, only transformed. Imagining the universe keeping careful track of everything, even in the quiet darkness of black holes, brings a sense of order and continuity. It feels like a gentle reminder that change doesn't mean loss. The cosmos, in its own calm way, holds on to every story, even those swallowed by gravity. Black holes affect their surroundings through tidal forces, stretching and squeezing matter as it approaches. Though this sounds intense, it happens gradually and follows predictable patterns defined by gravity. These tidal effects help scientists understand how matter behaves under extreme compression, giving clues about the limits of physics. The process is sometimes called spaghettification, but thinking of it softly feels more like imagining gravity slowly pulling things into thin, stretched shapes. This idea, while dramatic, unfolds with smooth mathematical consistency. It isn't chaotic or random. It follows clear rules set by the structure of spacetime. Visualizing these gradual gravitational stretches can feel like watching taffy being pulled slowly at a fair. Even in extreme conditions, the universe operates with quiet precision, turning motion and matter into flowing lines shaped by gravity's serene influence. Black holes help galaxies grow by regulating how much gas remains available for star formation. When a supermassive black hole becomes active, its energy can heat nearby gas and slow the birth of new stars. When it quiets down, the surrounding regions cool again, allowing stars to form more easily. This long, slow cycle creates a balance within galaxies, guiding their evolution over billions of years. The process is not sudden or violent when viewed on cosmic timescales. It's more like the gentle rise and fall of seasons, each phase influencing the next. Astronomers compare this influence to a cosmic heartbeat that sets the rhythm for the galaxy's growth. Imagining this slow, steady pattern helps us appreciate how black holes, despite their reputation, often play a stabilizing role. They help create order and structure, encouraging the calm development of stars and planets throughout the galaxy. A black hole's event horizon is often described as a point of no return, but imagining it gently makes it feel more like a quiet boundary where the universe changes its rules. Nothing special happens physically as you pass through. There is no wall or barrier. Instead, the mathematics describing space and time shift smoothly. From the viewpoint of someone falling in, the crossing is calm and undetected. This subtlety is one of the most peaceful aspects of black hole physics. It shows that even the universe's most dramatic thresholds can be soft and silent. Researchers like John Wheeler use the term black hole to help people imagine this mysterious region. But the true nature of the horizon is surprisingly simple. Thinking about it as a smooth, invisible surface where light pauses feels calming, like stepping from sunlight into shade with no sound or disturbance. Light behaves strangely around black holes. Instead of moving in straight lines, it bends and loops, creating arcs known as gravitational lensing. This bending is gentle and follows the curvature of spacetime. When viewed from afar, the light forms patterns that resemble halos or rings, called Einstein rings. These rings appear when light from a distant object passes near a black hole on its way to Earth. They are beautiful, symmetric shapes created entirely by gravity. The thought of light curving so gracefully can feel soothing, like watching ripples form perfect circles on water. Astronomers value these natural lenses because they let us see objects far beyond what our telescopes could normally detect. The universe, through its own quiet physics, helps reveal distant worlds by bending light in soft arcs. This delicate choreography makes black holes not just mysterious, but strangely elegant. Black holes can influence entire clusters of galaxies through their gravitational pull and energy output. In the center of large galaxy clusters, the supermassive black hole often acts like a quiet stabilizer, heating or cooling gas in long cycles that help the cluster maintain its structure. Though the scale is huge, the process unfolds slowly over millions of years. It's a gentle ebb and flow rather than a sudden event. Telescopes like Chandra have detected bubbles of gas created by these black holes, rising softly through space like warm air drifting upward. These bubbles help distribute energy evenly, similar to how currents stir the ocean in slow, calming movements. Thinking of black holes shaping whole clusters through such gradual processes gives a sense of the universe working with patience. Even at the largest scales, everything moves at a tranquil pace. The boundary of a black hole is more than just a mathematical surface. It behaves like a physical object in its own right, with properties such as temperature and entropy. According to the laws of black hole thermodynamics, the area of the event horizon can only increase, similar to how entropy in the universe always grows. This idea blends gravity, quantum physics, and thermodynamics into a single gentle principle about how the universe stays consistent. Jacob Bekenstein and Stephen Hawking helped reveal these connections, showing that black holes are not cold voids, but dynamic systems with underlying order. Thinking about the event horizon as a warm, softly glowing surface, metaphorically, can make the concept feel calm and alive. It's a quiet reminder that even in darkness, there are laws that keep everything balanced, guiding the universe like a steady pulse. Some scientists believe that black holes might be gateways to other regions of spacetime, though this idea remains theoretical. The concept of a wormhole emerges from solutions to Einstein's equations, suggesting a tunnel-like structure connecting two distant points. While there's no evidence that real black holes behave this way, imagining the possibility can be soothing, like thinking of hidden passages in the universe's architecture. Kip Thorne explored these ideas while helping design scenes for the movie Interstellar, ensuring they were grounded in real physics. Wormholes, if they exist, would be unstable and quick to collapse, but the idea behind them opens gentle questions about what space-time can do. It's less about the fantasy of travel and more about the calm curiosity the universe invites. Thinking of space containing hidden folds and tunnels feels like drifting through a dream where every corner might reveal something new. Even though black holes trap light, they can help us see the universe more clearly. When material falls toward them, it emits X-rays that telescopes like Chandra and New Star detect. These signals reveal the temperature, speed, and composition of gas billions of light years away. The radiation may sound intense, but it travels across the cosmos quietly, arriving as soft, faint waves of information. These observations help us study distant galaxies, early star formation, and the evolution of the universe. In a gentle way, black holes act like beacons, illuminating regions that would otherwise remain hidden. Thinking about these soft X-ray whispers crossing vast stretches of space gives a sense of deep cosmic calm. It reminds us that the universe communicates slowly and steadily, sending subtle clues about its distant corners. Black holes play a surprising role in spreading elements across galaxies. When stars collapse and form black holes, the outer layers of the star often explode outward in a supernova. These explosions scatter elements like carbon, oxygen, and iron into space, ingredients needed for planets and life. The black hole forms quietly at the center, while the galaxy around it receives fresh material. Over billions of years, this slow distribution of elements helps create new stars, new worlds, and eventually, life. Thinking of black holes as quiet recycling points makes them feel less like destructive objects and more like natural participants in the universe's long story. The cycle is slow, steady, and essential. It adds a peaceful perspective. Even in collapse, the universe prepares the way for new beginnings. Some black holes may form from the direct collapse of enormous gas clouds instead of stars, creating giants right at the beginning of the universe. These early black holes didn't need a supernova or a dramatic ending. They simply gathered mass quietly from the dense cosmic environment around them. Scientists believe these silent giants helped shape the first galaxies, guiding their growth like patient anchors. Instead of imagining explosions and chaos, think of these early black holes forming in a dim, newborn universe, where gas flowed slowly into calm gravitational wells. The conditions were simple and steady: cooling clouds, drifting matter, and gravity doing its quiet work. This gentle picture makes the early cosmos feel peaceful, almost like a dark ocean slowly settling after a long storm. These ancient black holes remind us that the universe often builds its grandest structures through slow, steady processes rather than sudden, loud events. The surface of a black hole may seem simple, but it carries one of the universe's deepest puzzles: how information is stored. The holographic principle suggests that everything falling in might be encoded on the event horizon, like patterns on a cosmic shell. This doesn't mean the surface has writing or symbols. It means the laws of physics may arrange information in a delicate, invisible structure. Thinking of the horizon as a smooth, soft boundary gently holding the universe's memories can be calming. The idea turns black holes from dark mysteries into quiet archives of cosmic history. Scientists like Gerard 't Hooft and Leonard Susskind explore these ideas to understand how quantum mechanics and gravity work together. Imagining the entire universe keeping its secrets folded neatly into the surfaces of black holes has a soothing feeling, like carefully storing precious notes in a safe, silent place. As stars orbit black holes, their paths become elegant curves shaped by gravity. These orbits are not chaotic. They follow predictable trajectories that trace out beautiful shapes in space. Some stars move at incredible speeds, but remain locked in smooth, stable loops around supermassive black holes. Observations of these orbits near Sagittarius A helped prove Einstein's theory of general relativity in the real universe, not just on paper. Imagining these stars circling in long, patient arcs can feel like watching glowing lanterns drift in a gentle night breeze. Even though the forces involved are enormous, the motion is soft and orderly. Nothing rushes, nothing stumbles. Everything follows the quiet geometry of space-time. These cosmic dances continue for millions of years, reminding us that gravity, even at its strongest, can guide matter into beautiful and calming patterns that inspire wonder rather than fear. When black holes feed on surrounding material, the process can create a bright and steady rhythm of light, known as quasi-periodic oscillations. These oscillations are gentle flickers caused by gas swirling in stable patterns near the event horizon. Scientists observe these signals as soft pulses in X-ray light, almost like the slow breathing of a sleeping giant. Although the environment near a black hole is extreme, the behavior of these flickers is surprisingly calm and rhythmic. They help researchers understand how matter behaves under intense gravity, offering clues about the structure of space-time itself. Thinking of these slow pulses feels like listening to a distant heartbeat echoing from deep space. The universe communicates in gentle rhythms, even in places filled with powerful forces. These quiet, repeating patterns remind us that nature often expresses its most complex ideas in steady, soothing motions that unfold over long periods. Some black holes are surrounded by large, faint halos of gas that stretch far beyond the visible accretion disk. These halos are made of cooler material, drifting lazily in the black hole's gravitational field. They glow softly in radio or X-ray wavelengths, creating a peaceful image of a dim, extended cloud around a dark center. Observing these halos helps scientists understand how matter flows in and out of black hole environments. Instead of imagining frantic motion, picture a slow swirl of cold gas gently orbiting, taking millions of years to move even small distances. The calmness of these halos contrasts beautifully with the strong pull of the black hole inside, reminding us that the cosmos is not always dramatic. Sometimes, the most extreme objects sit quietly inside wide, delicate structures that drift like morning fog around a still lake. Black holes can influence star formation by stirring gas clouds with their energy output. When they release gentle streams of particles or heat nearby regions, the surrounding clouds can condense in new ways, helping new stars take shape. This process doesn't happen quickly. It unfolds over millions of years, like a slow renovation of a galactic neighborhood. The black hole doesn't act as a destructive force. It acts more like a quiet gardener pruning and shaping the environment. Telescopes have captured scenes where these gentle outflows create pockets where young stars emerge, glowing softly in the dark. Thinking of a black hole guiding the birth of stars adds a peaceful dimension to their story. They aren't just cosmic traps, but also silent contributors to creation, encouraging new light to rise in calm regions of space. This perspective turns black holes into part of the universe's long, quiet cycle of renewal. In some galaxies, supermassive black holes send out gentle ripples of sound through the hot gas around them. These aren't sounds we can hear with our ears, but pressure waves detected by telescopes like Chandra. One of the most famous examples is in the Perseus cluster, where the black hole has created waves that have traveled for hundreds of thousands of light years. These waves carry a deep, steady tone, equivalent to a note far below the range of any musical instrument. Thinking of these enormous pressure waves as quiet cosmic hums gives black holes an unexpected musical quality. The universe itself seems to breathe in slow, deep vibrations shaped by gravity and energy. These sound waves are not violent. They drift softly through space like expanding ripples in a pond. The idea that galaxies have their own gentle songs can feel soothing, as if space is filled with hidden lullabies. Some black holes are surrounded by beautiful structures called circumbinary disks when two black holes orbit each other. These disks form wide, glowing rings of gas that circle around both black holes at once. Inside the disk, the black holes orbit each other in a slower, private dance. The motion is smooth and rhythmic, creating patterns that repeat over long periods. As the two black holes slowly spiral closer, the disk remains calm and orderly, feeding material inward like a quiet river. Simulations of these systems show soft waves and spirals forming in the gas, shaped gently by the gravitational influence of the binary pair. Watching these motions, even in animations, feels peaceful, like observing two lanterns drifting in a circular pool. These rare systems remind us that even when gravity pulls two massive objects together, the surrounding environment can respond with elegance and grace. The shadow of a black hole is not a physical object. It is the silhouette created when light bends around the event horizon. This shadow appears larger than the black hole itself, forming a soft ring-like shape. When the Event Horizon Telescope captured the first image of a black hole's shadow, the result looked almost like a warm ember floating in darkness. The glow came from material swirling in the accretion disk, but the dark center, the shadow, was the calm mark of gravity at its strongest. The shadow is steady, perfectly shaped by the geometry of spacetime. Imagining this circular silhouette can feel soothing, like looking at a dim eclipse. It represents a boundary where light slows, curves, and finally disappears, creating a natural artwork sculpted by gravity. This shadow is one of the clearest examples of how calm and orderly black hole physics can appear. Some black holes are surrounded by star clusters that orbit in tightly packed formations. These clusters contain thousands of stars moving in coordinated paths around the black hole. Despite the crowded environment, their motion remains surprisingly smooth, guided by the black hole's steady gravity. Observing these clusters helps scientists understand how black holes influence their surroundings across large distances. The stars behave like a vast glowing school of fish moving around a silent anchor in the ocean. Their orbits form patterns that repeat over millions of years, never hurried or chaotic. The entire cluster seems to breathe slowly, expanding and contracting with gentle gravitational interactions. Thinking of these luminous groups drifting together around a dark center gives a peaceful, almost meditative feeling. It shows that even in dense regions of space, order can emerge naturally, shaped by the quiet pull of gravity. Black holes can create gentle arcs of hot gas called filaments that stretch across space. These filaments form when magnetic fields guide the motion of particles near the accretion disk. Though the physics is complex, the image is simple and calming. Long, thin streams of glowing gas drifting outward in smooth curves. Observations with telescopes show these structures extending for light years, like delicate threads woven into the fabric of space. They change slowly over time, shaped by the stable rotation of the black hole and the soft movement of the surrounding gas. Imagining these filaments feels like watching strands of silk floating in a warm breeze. They reveal how gravity and magnetism can create elegant forms, even in extreme environments. These structures offer a reminder that the universe often expresses its power through quiet, sweeping gestures rather than sudden or chaotic bursts. Some black holes are part of triple systems, where a black hole orbits with two stars in a stable configuration. These systems are rare but fascinating because the motion of each object is balanced so carefully that the trio can remain stable for millions of years. The black hole quietly guides the system's rhythm, influencing the stars without disrupting them. From far away, the motion looks like a smooth, coordinated dance, with each object following its path with precision. These systems help astronomers understand how gravity works when multiple massive bodies interact. The gentle balance of forces creates an image of harmony rather than chaos. Thinking about three celestial objects moving together in perfect timing feels soothing, like watching synchronized swimmers move gracefully in still water. It shows that gravity, when allowed to settle into balance, can create peaceful and lasting arrangements. As gas spirals toward a black hole, it forms spiral arms similar to miniature versions of galaxy arms. These spirals are shaped by pressure, magnetic fields, and orbital motion. They twist inward slowly, guiding matter in graceful lines. Observing these spirals helps scientists study how order emerges naturally from motion. The arms don't crash or collide. They flow smoothly like currents in a calm ocean. The entire structure resembles a glowing whirlpool surrounding a dark center, spinning in silence. These patterns repeat in many different black hole systems, from stellar mass black holes to supermassive giants. Thinking of these glowing spirals feels peaceful, like watching golden dust swirl gently in a ray of sunlight. They show that even near a black hole, where gravity is strong, the universe creates shapes that are soft, predictable, and beautifully structured. A black hole's influence stretches far beyond what the eye can see. Its gravitational reach extends thousands of times farther than its event horizon. Yet this influence isn't harsh. It gradually shapes the motion of stars and gas, guiding them into stable orbits or smooth flows. This hidden structure helps hold galaxies together and maintain their graceful shapes. Astronomers map these gravitational fields by studying how stars move, revealing a quiet architecture built into space itself. Thinking about this invisible structure feels calming, like imagining a soft, unseen framework holding everything gently in place. Gravity isn't loud or forceful. It acts silently, shaping the universe with steady patience. Black holes simply amplify this natural order, creating regions where gravity's effect becomes more pronounced, but still follows smooth rules. This vast, quiet influence shows how deeply gravity organizes the cosmos in gentle, sweeping ways. When two black holes merge, the final black hole often wobbles slightly as it settles into its new shape. This wobbling is called ringdown, and it produces soft gravitational waves that fade slowly over time. These waves are like the gentle vibrations of a bell after it has been struck. The signal contains information about the black hole's mass and spin, helping scientists understand the final structure. Thinking of a newly formed black hole gently ringing as it relaxes feels surprisingly peaceful, like listening to distant chimes carried by a breeze. The motion isn't chaotic. It's a smooth decline of energy until perfect stillness is reached again. Ringdown is one of the universe's quietest and most elegant processes, a cosmic lullaby created after a long gravitational dance. The peaceful fade of these waves illustrates how even the strongest forces return to calm. Some black holes emit soft, low-frequency radio waves produced by electrons spiraling along magnetic field lines. These radio waves help astronomers map the structure of the space around the black hole. They travel gently across the cosmos, carrying information about magnetic fields, temperatures, and motion. These signals are not bursts or explosions. They are steady streams of energy that drift through space like quiet whispers. Telescopes translate them into images showing smooth, flowing shapes that reveal how matter behaves near the event horizon. Thinking about these slow, calm radio waves moving through the universe adds a peaceful dimension to black hole physics. They show that even in extreme regions, communication happens softly. Space is filled with delicate signals traveling gracefully across unimaginable distances, offering a serene picture of how energy moves in gentle, continuous waves. Black holes help stir the interstellar medium by creating gentle winds that push nearby gas. These winds form when energy from the accretion disk transfers to particles and sends them drifting outward. The motion is slow compared to explosive events like supernova, but over millions of years, the winds shape the environment around the black hole. They create soft bubbles and arcs in the gas, like the patterns left behind when a boat moves through calm water. These subtle structures help regulate star formation and influence the layout of gas clouds. Thinking of these slow, patient winds gives a peaceful image of black holes as quiet sculptors shaping their surroundings. The universe doesn't rush. It molds its structures gradually, letting small forces accumulate into large, graceful patterns over long cosmic ages. Some black holes drift through galaxies with their own tiny entourage of planets or remnants left from the star that collapsed to form them. These planets do not orbit with sunlight. Instead, they follow the steady pull of gravity in complete darkness. Yet their motion remains calm and predictable, shaped by the same laws that guide planets around ordinary stars. Scientists think these systems may be surprisingly common, hiding silently in the Milky Way. Even without light, the gravitational balance allows the planets to circle smoothly for billions of years. Thinking of these dark planetary systems creates a peaceful picture. Quiet worlds moving in slow, perfect loops around an invisible center. They remind us that harmony in the universe doesn't always need brightness. Sometimes balance exists in silence, guided only by gravity's gentle hand. These unseen systems show that even in darkness, order and stability persist in soft, elegant patterns. Black holes may influence cosmic rays, the energetic particles that travel across the galaxy. As matter accelerates near the event horizon or within powerful jets, some particles escape with tremendous speed. Even though the physics sounds intense, the process unfolds smoothly, guided by magnetic fields that twist and shape the particles' paths. Over long distances, these particles drift through space like tiny travelers, carrying clues about where they came from. Scientists detect them on Earth and trace their origins back to active galactic nuclei powered by black holes. Thinking about these particles moving slowly across light years feels calming, like watching small leaves floating along a wide, gentle river. Their journey is steady and patient, shaped by forces that operate quietly across vast distances. These cosmic rays remind us that the universe spreads information, not through loud bursts, but through subtle signals that drift like whispers across space. When galaxies collide, the central black holes slowly approach each other across millions of years. During this long approach, they stir the surrounding gas and stars, creating smooth waves of motion that spread gradually outward. The process is not chaotic when viewed on cosmic timescales. It is a slow reorganization, like two large tides blending into one another. Eventually, the black holes form a binary pair, orbiting in graceful curves before merging. The gradual pull they exert helps the galaxies settle into new shapes, smoothing their structures over time. Thinking about this slow convergence feels peaceful, like watching two drifting clouds slowly combine. The universe allows even its largest events to unfold without urgency. The calm, steady gravity of black holes guides galaxies into new forms, showing that creation and transformation often happen through long, patient motions rather than sudden change. Some black holes appear to flicker in brightness because the gas swirling around them shifts slowly over time. These changes are not chaotic flashes. They are soft variations caused by the gentle rearrangement of matter in the accretion disk. Gas may thicken in one region or thin in another, creating a slow pulse of light that astronomers record as a subtle dimming or brightening. These changes can repeat over days, months, or even years. Thinking of this flickering feels like imagining a lighthouse whose glow rises and falls with the rhythm of the sea. The black hole remains steady. Only the surrounding material shifts in soft, natural patterns. This quiet variability helps scientists study how matter behaves under gravity without needing sudden or violent events. The gentle glow reveals a calm, ongoing conversation between gas and spacetime, unfolding slowly and rhythmically in the dark. Black holes can subtly shape the structure of spiral galaxies by influencing how stars and gas move in the central regions. Their gravity anchors the inner orbits, helping maintain the smooth rotation that gives spirals their elegant shape. Without a stable center, the swirling arms might not hold their structure as well. This influence is not forceful. It's a quiet, stabilizing effect that keeps the central region organized. Thinking of a black hole as the still point at the heart of a turning galaxy creates a calm image, like the center of a spinning wheel remaining perfectly motionless. Billions of stars swirl around this steady anchor, following patterns set by gravity's gentle guidance. This idea gives the universe a feeling of order and calm, showing how even the most massive objects support harmony in the grand structure of galaxies. Black holes sometimes create gentle arcs of warm dust in the regions surrounding them. These dusty structures glow faintly in infrared light and drift slowly through space. The dust grains are heated by nearby stars or by the soft radiation the black hole's environment produces. Over time, the dust settles into curved lanes shaped by gravity and pressure. These lanes look like delicate brushstrokes across the galaxy, painted over millions of years. Scientists study these patterns to learn how gas and dust circulate in galactic centers. The slow motion of these dust lanes feels peaceful, like watching smoke drift in a still room. Even though the environment near a black hole contains strong forces, the dust moves with gentle consistency, tracing smooth paths that reveal the underlying calm structure of spacetime. These dust arcs show how beauty can emerge naturally from slow, quiet processes. Some black holes are located in dwarf galaxies, tiny systems with just a few million stars. These small galaxies host surprisingly massive black holes that sit quietly at their centers, shaping the galaxy's simple structure with gentle gravitational influence. Because dwarf galaxies are less crowded, the black hole's presence feels even more peaceful. There is no thick traffic of stars rushing past, only small, slow orbits drifting through space. Studying these systems helps scientists understand how the earliest galaxies formed in the young universe. The picture is calm, a small galaxy moving softly through cosmic darkness with a quiet black hole at its core. Thinking of these tiny galactic worlds gives a sense of simplicity and ease, like small islands drifting on a vast, calm ocean. These miniature systems remind us that even the universe's grand physics can appear gentle when scaled down to quieter environments. Black holes may help create long-term stability in star clusters by absorbing stray stars that drift too close. This doesn't happen quickly. It unfolds over millions of years, with stars gradually nudged inward by gravitational interactions. When a star finally crosses the critical distance, the black hole quietly incorporates its mass. This process helps keep the remaining cluster more stable, preventing chaotic motion. Thinking of the black hole acting as a quiet center that tidies the system gives a soothing perspective. Nothing is rushed, and the cluster continues to breathe slowly over time. Astronomers use these interactions to study both stellar dynamics and black hole growth. The interaction feels less like destruction and more like the gentle rebalancing of a crowded system, allowing the cluster to remain harmonious for long periods. This view makes black holes feel like patient caretakers, maintaining equilibrium in ancient, drifting communities of stars. Some black holes are predicted to be so small they could fit inside a mountain, yet still carry the mass of a large star. These hypothetical objects, called primordial black holes, may have formed shortly after the Big Bang. If they exist, they drift quietly through the universe, dark and silent. Their existence would add a calming layer to the early cosmos, suggesting that even the infant universe evolved with careful balance. These tiny black holes wouldn't cause dramatic events. They would simply glide through space like small pebbles moving along a riverbed. Scientists search for their subtle gravitational influence to determine whether these ancient objects might explain certain observations today. Imagining a universe filled with tiny, unseen pockets of gravity creates a soothing picture, like gentle knots woven into a vast fabric. These primordial black holes symbolize the universe's ability to form structure through calm, natural processes. Dust and gas near black holes often form winds that rise upward in smooth, gentle flows. These winds don't erupt violently. They drift outward slowly, following magnetic field lines and pressure gradients. Over time, They form soft cones or arcs that shape the surroundings in graceful patterns. Astronomers observe these winds using X-ray and ultraviolet telescopes, studying how they influence star formation and galactic structure. These flows act like quiet breaths around the black hole, exhaling energy that spreads through the nearby environment. Imagining these soft winds feels calming, like watching mist rise from a lake at dawn. They reveal how energy moves through the universe in steady, controlled ways. Even near a black hole, where gravity is intense, the outflow of gas remains gentle and rhythmic, a reminder that nature often prefers smooth transitions over sudden bursts. Some black holes create areas of gently glowing gas far from their centers, where the radiation they emit heats surrounding clouds. These illuminated regions can stretch for thousands of light years, lighting up space with soft colors. The glow is steady and long-lasting, a slow response to the black hole's energy output. Observations in visible and infrared light show smooth gradients of color shining quietly in the darkness. Thinking of these glowing clouds feels peaceful, like soft lanterns floating in a wide night sky. The black hole at the center remains unseen, yet its influence spreads outward in a calm, steady way, shaping the appearance of entire galactic neighborhoods. These glowing regions reveal how black holes communicate with their surroundings through gentle, sustained energy, rather than abrupt flashes, adding an elegant calmness to the cosmic landscape. The outer regions around black holes sometimes contain knots of cool gas drifting slowly through the gravitational field. These knots form when gas clumps together under pressure, creating small, dense pockets. As they move, they trace delicate paths that curve gently around the central object. Observations show that these knots persist for long periods, surviving in the quiet outskirts of the black hole's influence. Their motion is slow and graceful, like drifting petals carried by a faint breeze. Scientists study these knots to understand how matter organizes itself near energetic environments. Despite the power of the black hole, these cool clumps remain intact, reminding us that calm structures can exist even in dynamic regions of space. Their soft motion paints a quiet picture of the universe at work, shaping matter through gentle, continuous forces rather than chaotic bursts. Some black holes help create wide cavities in the gas around them, leaving behind soft, bubble-like structures. These bubbles form when outflows push gently against nearby material, carving smooth hollows over millions of years. The edges of these cavities glow faintly, marking where energy has warmed the gas. These shapes resemble round, drifting clouds suspended in space. Astronomers use them to study the slow feedback cycle between black holes and galaxies. Thinking of these bubbles gives a sense of calm expansion, like watching air pockets rise through still water. The process is slow and relaxing, revealing how immense forces can produce delicate, rounded shapes. These cosmic bubbles show the gentle side of black hole activity, illustrating how energy can spread softly and quietly through space. Black holes can guide the motion of interstellar gas into spiral inflows that stretch for thousands of light years. These inflows resemble winding rivers of dust and gas gently curving toward the galactic center. The movement is slow, smooth, and steady, shaped by gravity and pressure. These spirals are visible in many galaxies, forming elegant pathways that feed material gradually inward. Thinking of these long cosmic rivers feels peaceful, as if the galaxy itself is slowly exhaling patterns of dust toward the center. The inflows help support long-term star formation and maintain the quiet balance of matter in the galaxy. Their beauty lies in their simplicity and predictability, showing how natural order emerges under the steady influence of gravity. These spiraling paths offer a tranquil view of how galaxies move material in smooth, unhurried lines. Black holes sometimes shine softly in infrared light as warm dust heats up around them. This glow is not intense or blinding. It forms a gentle halo that radiates steadily through the darkness. Infrared telescopes capture these halos as smooth, rounded shapes that shift slowly over time. The light reveals regions too dusty for visible wavelengths, showing the quiet warmth surrounding the black hole. Thinking of this gentle glow brings a sense of calm, like the faint warmth of embers lighting a dark room. The black hole remains hidden, but the surrounding dust responds with soft, radiant energy. This infrared emission helps astronomers map both the environment and the slow changes in temperature over long periods. The image of a quiet, warm halo in space adds a serene dimension to black hole environments. Some black holes help shape the motion of entire galactic bars, the long structures of stars that stretch across spiral galaxies. Their gravity supports the bar's rotation, keeping it stable as stars drift along smooth, elongated paths. This influence is subtle but important, allowing the bar to guide gas into the galaxy's center where new stars form. Thinking about this calm steering effect feels peaceful, like a gentle hand guiding a slow-moving wheel. The black hole's gravity doesn't disrupt the structure. It stabilizes it, helping maintain the galaxy's elegant shape. Studying this interaction reveals how deeply black holes contribute to the quiet order of galaxies. They act as silent organizers, supporting the rhythmic motion of stars and gas. This role transforms the idea of black holes from fierce gravitational traps into steady, patient partners in the universe's architecture. Black holes sometimes exist near regions rich with star-forming gas, influencing these regions with gentle gravitational nudges. Instead of pulling everything inward, they often help compress gas in certain places, encouraging star birth. This process unfolds slowly, like a quiet collaboration between gravity and gas clouds. The presence of a black hole doesn't disrupt the region. It shapes it with delicate influence. Thinking of a black hole helping new stars ignite gives a warm feeling, as if darkness and light work together in harmony. These regions glow softly with young stars, each one a product of long, slow gravitational guidance. This perspective shows how black holes participate in creation, not only destruction, supporting the calm cycles that give galaxies their light. Some black holes influence the paths of high-energy photons passing nearby, bending them into elegant curves that help scientists study distant cosmic objects. This bending is gentle, guided entirely by the curvature of spacetime. The resulting arcs and rings, called gravitational lenses, reveal galaxies that would otherwise be too faint to detect. Thinking of light being gently redirected rather than stopped creates a soothing image, like a stream flowing around a smooth stone. The black hole doesn't disrupt the light. It guides it into new shapes that paint beautiful patterns across the sky. This quiet effect allows astronomers to observe deep regions of space, using black holes as natural telescopes. The soft bending of light shows how gravity can produce calm and graceful distortions that help us understand the universe's distant secrets. Black holes play a role in shaping the temperature of the gas within galaxy clusters. Their energy warms the surrounding gas slowly and steadily, preventing it from collapsing too quickly into new stars. This heating happens over millions of years, creating a long-term balance between cooling and warming. The result is a stable environment where the cluster evolves in calm cycles. Thinking of this process feels like imagining a slow climate system that changes gently over immense timescales. Nothing happens suddenly. The black hole's influence acts like a soft thermal regulator guiding the state of the cluster. Astronomers study these patterns to understand how cosmic structures remain stable across billions of years. The gentle interplay between heating and cooling creates a peaceful picture of the universe maintaining balance. Some black holes sit inside regions filled with cold molecular gas, and their influence helps shape the slow drift of these clouds. The gas does not rush inward. Instead, it moves with soft, gradual motions, guided by the long pull of gravity. Over time, the clouds stretch into smooth arcs that curve gently toward the center. These calm shapes help scientists understand how galaxies distribute matter over millions of years. Thinking of these cold clouds drifting through space feels peaceful, like watching fog slide slowly across a quiet hillside. The black hole does not disturb the gas. It simply provides a distant anchor that the clouds respond to with steady, unhurried motions. These regions show how quiet and graceful the universe can be, even near massive objects. The soft, drifting clouds create a serene picture of the cosmos, where gravity paints gentle patterns across vast stretches of space. Black holes may influence the alignment of magnetic fields in their surroundings. Near the accretion disk, magnetic field lines stretch and twist in smooth curves, creating organized shapes that hold gas in steady patterns. These fields guide charged particles into clean, natural paths, giving structure to the swirling environment. Observations using polarized light show that these magnetic lines behave like gentle threads woven around the black hole. Thinking of magnetic fields forming soft loops feels calming, like strands of yarn being wrapped neatly around a quiet center. The fields do not act chaotically. They respond to the flow of gas and the rotation of the black hole with slow, controlled motion. This organized structure helps scientists understand the balance between gravity, motion, and energy. It paints a picture of the universe as a place where even invisible forces arrange themselves into elegant, orderly patterns. Some black holes help create large, faint rings of gas far from their centers. These rings form when outflows gently push material outward before it settles into smooth orbits. Over millions of years, these structures become wide, delicate circles, drifting quietly in the outer parts of galaxies. The rings glow softly in ultraviolet or infrared light, revealing patterns shaped by time and patience. Thinking about these enormous, softly lit rings makes the universe feel peaceful, like ripples expanding slowly across a still lake. The black hole's influence is indirect but steady, guiding matter into calm, circular paths. Scientists study these rings to learn how galaxies evolve around their central objects. The image of a wide, faint ring floating silently in space adds a tranquil beauty to the cosmos, showing how black holes can shape their surroundings with gentle precision rather than violent force. Some black holes are surrounded by faint, drifting arcs of ionized gas that glow softly in radio wavelengths. These arcs are shaped by gentle pressure from outflows, creating curved, ribbon-like structures that move slowly through the galaxy. The motion is so smooth that the arcs can remain intact for millions of years. Observing them feels like watching soft trails of smoke float through a quiet room. The black hole's influence is subtle, guiding the motion without disrupting the structure. These delicate arcs help scientists understand how energy spreads through galactic environments in slow, steady ways. The calm curves and faint glow create a serene picture of space, where matter moves not in bursts, but in flowing, graceful shapes. These peaceful structures remind us that even in regions filled with strong forces, the universe often behaves with soft, quiet elegance. Black holes can contribute to the slow stirring of intergalactic gas, the thin material that lies between galaxies. Their activity sends out waves of energy that travel great distances, nudging the gas gently and helping distribute heat. These waves move slowly, taking millions of years to reach different parts of a galaxy cluster. Thinking of these long traveling waves feels soothing, like gentle ripples spreading across an enormous pond. The black hole acts not through explosions, but through soft, persistent energy output that helps maintain balance in the cluster. Observations show smooth gradients of temperature that reveal how these waves influence the gas. This slow, gentle interaction gives the universe a sense of calm order, where even the largest structures respond to subtle, steady forces. The idea of energy drifting quietly through intergalactic space adds a serene layer to the story of black holes. Some black holes have faint companions, stars that orbit at great distances in long, slow loops. These stars take thousands or millions of years to complete a single orbit. Their motion is gentle, pulled steadily by the black hole's distant gravity. Scientists observe these orbits to measure the black hole's mass with precision. The stars themselves remain undisturbed, glowing quietly as they drift through vast arcs of space. Thinking of these distant companions feels peaceful, like lanterns circling slowly around an unseen center. Nothing rushes. Everything follows the calm geometry of gravity. These long, slow orbits show how black holes influence their surroundings in graceful, predictable ways. The quiet companionship between the black hole and its distant star gives a serene picture of cosmic balance, where even massive forces produce motion that is smooth and harmonious across enormous stretches of time. Some black holes produce soft, low-density winds that drift outward through the galaxy. These winds do not sweep violently. They flow gently, carrying thin streams of particles into distant regions. Over long timescales, these winds help shape the temperature and composition of the galaxy's inner regions. Scientists detect them using X-ray and ultraviolet observations, which show smooth, steady outflows rather than abrupt bursts. Thinking of these gentle winds feels like imagining warm air rising slowly in a quiet valley. They move with calm consistency, influenced by the steady energy of the accretion disk. These winds reveal the universe's preference for gradual change, allowing structures to evolve softly over millions of years. Even the smallest outflows contribute to the quiet shaping of galactic environments, showing that black holes participate in the slow, peaceful rhythms of the cosmos. Some black holes influence the motion of dense molecular rings that form around galactic centers. These rings hold cold gas that moves in smooth, circular paths shaped by the gravity of the central black hole. The gas travels slowly, completing orbits over tens of millions of years. Observations show that these molecular rings remain stable for long periods, glowing softly in millimeter wavelengths. Thinking of these cold, gentle rings circling the center of a galaxy feels calming, like watching distant clouds rotate around a quiet mountain peak. The black hole acts as a steady anchor, guiding the motion without disturbing the ring structure. These stable rings help astronomers trace the distribution of material in galactic centers and understand how star formation cycles evolve. Their soft, steady motion paints a peaceful picture of the universe, conserving order through patient, circular patterns. When black holes rotate rapidly, they create a smooth, flattened shape called the photon orbit, a region where light can circle the black hole in perfect loops. This orbit is not visible to the eye, but simulations reveal it as a glowing, circular ribbon around the event horizon. Thinking of light moving in endless smooth circles feels soothing, like watching a tiny halo hover silently in space. The orbit represents one of the cleanest examples of space-time curvature, where gravity guides light into flawless paths. These loops show how precisely the universe operates, even in extreme environments. The photon orbit is stable and elegant, offering a peaceful image of light moving in harmony with gravity. Scientists study these orbits to learn how the structure of space-time behaves near black holes. The idea of light gliding in quiet, perfect circles gives the cosmos a sense of calm symmetry. Some black holes quietly influence the chemical composition of their surrounding regions by heating gas just enough to trigger gentle reactions between atoms. This process can alter the balance of elements in a slow, predictable way. Instead of explosions or sudden changes, the chemical evolution unfolds like a gradual shift in temperature in a quiet room. Over millions of years, these reactions create new molecular structures that help form stars and planets. Thinking of a black hole indirectly encouraging chemistry feels peaceful, as if it plays a quiet supporting role in the long formation of cosmic environments. Scientists study these chemical gradients to understand how black hole activity shapes the evolution of galaxies. The calm, slow influence adds nuance to black holes' role in the universe, showing that even intense gravity can support delicate processes when viewed over long timescales. Some black holes are surrounded by thick tori of dust, donut-shaped clouds that circle the center in slow, steady rotation. These tori absorb light from the accretion disk and re-radiate it softly in infrared wavelengths. They move so slowly that a full rotation can take thousands of years. Thinking of these dusty rings circling a quiet center brings a sense of stillness, like watching a slow-moving storm cloud drift across a calm sky. These tori help regulate the flow of material into the black hole, acting like gentle barriers that control how fast the central region grows. Their steady motion reveals a subtle balance between gravity, pressure, and light. Scientists study these structures to understand the hidden environments of active galactic nuclei. The image of a soft, dusty ring rotating quietly in the dark adds a soothing layer to the nature of black holes. Some black holes sit inside regions filled with extremely diffuse plasma, where particles drift so far apart that collisions are rare. In these environments, the plasma moves with slow, graceful currents shaped by magnetic fields and gentle gravitational pull. The motion is so calm that it resembles a cosmic fog drifting through space. Scientists observe these regions using radio telescopes, mapping the slow flow of particles that respond to the black hole's influence. Thinking of such a faint plasma cloud feels peaceful, like watching a thin mist move through moonlight. The black hole at the center remains hidden, but its presence subtly shapes the environment with no sudden movements. These quiet plasma regions help astronomers understand low-density environments in galaxies and clusters. Their delicate motion shows how even the most diffuse matter follows the universe's soft, orderly rhythm. Some black holes help form elegant arcs of starlight when their gravity bends the paths of photons passing through nearby galaxies. These arcs appear as gentle curves stretched across the sky, created by the smooth bending of space-time. The light itself comes from distant galaxies, but the black hole acts like a quiet sculptor, shaping the beam into an arc before it reaches us. Thinking of starlight being softly curved by gravity feels calming, like a beam of light flowing through water and bending gently. These arcs help scientists map the distribution of mass around black holes and study hidden structures in distant galaxies. The graceful shapes serve as visual reminders of gravity's ability to create beauty through simple, natural motions. These arcs are among the universe's most delicate artworks, formed without sound or force, only the quiet curvature of space-time. Some black holes help trigger slow cycles of cooling and heating in the gas surrounding them. Over millions of years, gas cools and begins to sink inward, only for the black hole's energy output to warm it again and push it outward. This quiet back and forth motion acts like a cosmic breathing pattern, maintaining balance in the galactic center. Thinking of this cycle feels peaceful, like watching a tide rise and fall in rhythmic harmony. The process prevents runaway star formation and keeps the region stable for long periods. Scientists call this feedback regulation, but the underlying idea is simple: calm, slow adjustments that maintain equilibrium. This rhythmic exchange creates a soothing picture of the universe acting with patient consistency rather than sudden change. Black holes, often seen as destructive, instead appear as gentle regulators participating in cosmic harmony. Some black holes influence the flow of stellar streams, long trails of stars created when galaxies interact or merge. These streams move like soft ribbons stretched across space, and when they pass near a black hole, their paths curve gracefully. The change is slow and smooth, revealing the shape of the gravitational field. Thinking of these glowing streams bending gently feels calming, like watching a long scarf float on a still breeze. The stars continue their journey unharmed, drifting in elegant arcs guided by gravity. Scientists study these streams to learn about black hole masses and the structure of galaxies. The gentle deflection adds a peaceful note to the way black holes interact with stellar populations, showing how even massive objects can guide motion without violence. These curved streams highlight the quiet, artistic side of cosmic gravity. Some black holes quietly influence the tilt of the gas disks that orbit them. Over long periods, the disk can slowly warp into a soft, curved shape, guided by the black hole's spin and the gentle drag of gravity. These warps form smooth waves that travel around the disk, rising and falling in steady rhythms. Thinking about these gentle ripples creates a calming image, like soft waves moving across a wide, silent pond. The disk remains stable even as it tilts, responding gradually to the forces around it. Scientists study these warped disks to understand how black holes rotate and how their gravity interacts with distant material. The slow, graceful bending reveals how calmly the universe adapts to changes in motion. These soft curves show that even near powerful objects, the cosmos often expresses its behavior in smooth, delicate patterns rather than sudden shifts. Some black holes sit in regions where stars form in clusters around them, creating a soft glow that surrounds the central darkness. The black hole's gravity holds these stars in long, delicate orbits that trace gentle loops through space. Over millions of years, the cluster evolves slowly as stars drift, age, and shift position. Thinking of a black hole resting quietly inside a glowing cluster makes the universe feel warm and peaceful, like a lantern shining in the night with a calm center. The black hole doesn't disrupt the cluster. It only anchors it, providing stability for the star's graceful motion. Scientists observe these clusters to learn how gravity organizes densely packed environments. The picture is serene. Thousands of stars drifting softly around an invisible center, each one glowing like a small ember floating through quiet darkness. Some black holes help shape vast cavities in galaxy clusters, creating hollow regions filled with faint, warm gas. These cavities form slowly, carved by gentle outflows that push against the surrounding material over millions of years. The edges of these cavities glow softly, revealing curved walls shaped with patience rather than force. Thinking of these enormous hollows feels calming, like watching bubbles rise slowly through thick liquid. The black hole's influence isn't violent. It is a steady pressure that guides the cluster's evolution with quiet persistence. Astronomers study these cavities to understand how black holes regulate the temperature and movement of gas across huge distances. The smooth, rounded shapes give the cosmos a sense of softness and order, showing how even the most massive environments can shift in gentle, controlled ways when influenced by steady cosmic forces. Some black holes influence the paths of galaxies that drift past them over enormous distances. The gravitational pull they exert is subtle but steady, gently curving the trajectories of galaxies that happen to travel near their reach. This interaction unfolds over billions of years, creating slow arcs in the motion of entire galaxies. Thinking of a black hole gently guiding the path of something so vast feels peaceful, like a single stone subtly redirecting the flow of a wide, calm river. These small gravitational nudges help astronomers map the distribution of mass across the universe. The process is quiet and patient, showing how gravity connects distant objects with soft, invisible threads. The graceful bending of galactic paths adds a serene dimension to the cosmos, where even the largest structures move in smooth, gentle lines shaped by time and gravity. Some black holes have faint, drifting streams of stars that orbit them after past interactions with smaller galaxies. These streams are long, thin ribbons of starlight stretched across space, moving in peaceful arcs. The black hole's gravity guides them with slow precision, shaping their paths like a hand tracing curves in sand. Over time, the streams maintain their shape, offering a clear view of the gravitational environment. Thinking about these drifting stellar ribbons feels calming, like watching trails of soft light glide through dark water. Scientists study these streams to understand the history of galactic mergers and how black holes influence surrounding stellar populations. The motion is gentle and patient, revealing how the universe records its past through elegant, lingering patterns. These stellar streams show that cosmic memory can appear as soft, glowing lines stretched across the darkness. Some black holes sit inside regions where gas forms thin, layered sheets that drift gently inward. These layers move like pages of a book sliding slowly toward the center. Each layer interacts softly with the next, creating smooth flows shaped by pressure and gentle gravitational pull. Scientists observe these structures to understand how matter approaches the event horizon in calm, orderly patterns. Thinking of these layered sheets drifting inward feels soothing, like watching soft fabric fold itself in quiet motion. The black hole doesn't tear the gas apart. It guides it inward in a patient, spiraling flow. These gentle layers reveal how even extreme environments can behave with surprising tranquility. The slow, inward drift paints a peaceful picture of gravity leading matter toward its center without chaos. Just soft, persistent motion unfolding over long cosmic timescales. Some black holes influence the rotation of entire gas clouds that extend thousands of light years from their center. These clouds spin slowly, guided by the far-reaching pull of gravity. Their rotation is smooth and predictable, unfolding over millions of years like a quiet wheel turning in space. Observations show that these clouds maintain their structure despite their size, revealing how consistent the gravitational field remains even at great distances. Thinking of these massive clouds rotating calmly around a black hole feels peaceful, like watching a distant galaxy swirl in slow motion. The black hole's influence is subtle but steady, creating harmony in the movement of vast amounts of gas. Scientists use these rotations to understand how mass is distributed across galactic centers. The gentle spin of these clouds adds a soft, elegant rhythm to the story of the cosmos. Some black holes subtly shape the movement of cosmic dust that flows along magnetic field lines. These dust grains drift in long, slow arcs, following paths determined by the quiet structure of the field. From far away, the motion looks like soft threads floating through a still stream of air. The black hole's gravity influences the magnetic field indirectly, helping create stable, delicate patterns in the dust. Thinking of these drifting grains adds a peaceful detail to the cosmic environment, showing that even tiny particles respond gracefully to large-scale forces. Scientists study these patterns to understand the interplay between magnetism, dust, and gravity in galactic centers. The gentle traces of dust create a picture of the universe as a place filled with soft, flowing shapes that move quietly through endless space. Some black holes contribute to the gentle rotation of entire galaxy clusters by influencing the motion of gas and dark matter at their centers. This influence is extremely subtle, acting over billions of years, but it can help maintain the slow spin of the cluster as a whole. Thinking of a black hole affecting such enormous structures with quiet, patient gravity creates a calming image, like a small weight guiding the slow turn of a massive wheel. The cluster evolves softly, adjusting its rotation through delicate interactions that leave no sudden marks. Scientists study these motions to understand how clusters grow and settle into stable shapes. The black hole's role is a reminder that even the most powerful cosmic objects can act with elegance and gentleness, shaping motion across vast distances without forceful disruption. Some black holes guide the collapse of gas into long, graceful filaments that stretch toward the center of a galaxy. These filaments form when gas cools and sinks slowly inward, pulled by the steady gravity of the black hole. The filaments glow in faint light, creating delicate pathways that resemble soft, flowing veins through space. Thinking about these structures feels peaceful, like watching thin streams of water trickle down a smooth surface. The black hole's influence is steady and patient, shaping these filaments over millions of years. Scientists study them to understand how galaxies transport material toward their centers and how new stars eventually form from these quiet flows. The soft curved lines of the filaments add beauty and tranquility to the cosmic landscape. Some black holes affect the gentle drift of high-altitude gas far above their accretion disks. This gas moves slowly in wide, arching loops shaped by magnetic fields and gravity. These loops can rise and fall in steady cycles, creating a calm, wave-like pattern around the black hole. Thinking of these loops adds a calming rhythm to the environment, like watching long kelp strands sway softly beneath ocean waves. The motion is consistent and peaceful, revealing the quiet interplay between gas, magnetism, and gravitational pull. Scientists observe these loops to learn how energy is transported through the region and how material circulates before falling inward or drifting away. These soft arcs of gas show that even in energetic surroundings, gentle patterns remain dominant over long periods. Some black holes sit inside galaxies where the central region produces a soft haze of light created by trillions of tiny dust particles reflecting starlight. This shimmering haze forms a warm glow that surrounds the black hole, giving the galactic center a quiet, lantern-like appearance. Thinking of this soft illumination creates a peaceful picture, like golden dust drifting in a sunbeam. The black hole remains invisible, but its gravitational presence helps organize the stars and gas that produce the glow. Scientists study this soft light to understand the dense environments in galactic centers. The gentle shimmer makes black holes feel less like dark voids and more like quiet hearts at the center of glowing communities. Some black holes influence the motion of ultra-diffuse galaxies, large, faint galaxies with very few stars. These galaxies drift through space like soft shadows, held together partly by the gravity of a central black hole. The motion of their stars is slow and delicate, tracing wide paths through dim regions. Thinking of these faint galaxies feels calming, like watching mist drift across a moonlit field. The black hole's presence helps preserve the galaxy's loose structure, keeping it from dispersing entirely. Scientists study these systems to understand how even minimal amounts of matter can remain stable under gentle gravitational guidance. The soft outlines of ultra-diffuse galaxies reveal a quieter side of the cosmos. Some black holes help generate long, slow ripples of magnetic pressure that move outward through their surrounding gas. These ripples act like soft, expanding rings, guiding the motion of particles without sudden changes. Over millions of years, they shape the structure of the central region, adding gentle layers to the galaxy's organization. Thinking of these ripples feels peaceful, like watching concentric waves spread across a still pond. Scientists observe these patterns to learn how energy is distributed in active galactic nuclei. The calm, steady expansion reveals how black holes contribute to smooth, continuous evolution instead of chaotic disruption. Some black holes sit near regions filled with ancient stars that orbit in long, looping paths shaped by gravity. These orbits persist for billions of years, forming a stable, glowing halo around the central darkness. Thinking of this serene arrangement feels calming, like tiny fireflies circling a quiet clearing. The black hole supports the balance of these old stars, helping maintain the structure of the galactic center. Scientists study these ancient populations to learn how galaxies form and evolve over cosmic time. The quiet motion of these stars gives a peaceful sense of enduring order. Some black holes influence the rotation of entire disks of ionized gas that glow softly in various colors. These disks move in smooth circular paths, their temperature rising gently closer to the center. The glow they produce forms a calm, layered spectrum of light. Thinking of these colored disks orbiting silently around a black hole feels soothing, like watching watercolor paint swirl gently across paper. Scientists observe these disks to measure the speed and structure of matter near black holes. The soft rotation and glowing layers offer one of the most serene images of a black hole's environment. Some black holes create long, faint trails of energized particles that drift quietly into intergalactic space. These trails stretch across hundreds of thousands of light years, forming soft, wispy lines that glow in X-ray or radio light. Thinking of these trails feels peaceful, like watching long clouds stretch across a pale sky. The particles travel gently, influenced by magnetic fields and gravity. Scientists use these trails to study the flow of energy from black holes into large-scale cosmic structures. The calm, continuous drift of these particles shows how the universe spreads energy softly and steadily over time. Some black holes influence the shape of spiral arms in galaxies by guiding gas inward along smooth paths. This slow inward flow helps maintain the spiral structure over long periods. Thinking of a black hole supported at the center of a spiraling galaxy gives a peaceful image, like the still point at the middle of a slowly turning whirlpool. The motion of gas and stars remains smooth and coordinated, revealing how gravity creates balance rather than chaos. Scientists study these interactions to understand how galaxies keep their elegant shapes. The quiet guidance of the black hole adds harmony to the overall structure. Some black holes sit near regions that produce soft X-ray glows created by gently heated gas. These glows pulse slowly as the gas warms and cools in repeating cycles. Thinking of this soft, pulsing light feels calming, like distant embers breathing in and out. The black hole provides a steady source of energy that maintains the gentle rhythm. Scientists observe these cycles to understand how gas behaves under long-term heating. The slow, peaceful flicker of X-ray light adds a soothing heartbeat to the cosmic environment. Some black holes help maintain the stability of nuclear star clusters, dense groups of stars found at the centers of galaxies. The black hole's gravity provides a central anchor that organizes the cluster's motion. Thinking of a nuclear star cluster moving softly around a silent black hole feels calming, like a swirling cloud of fireflies drifting around a still center. The cluster evolves slowly, with stars moving in gentle, coordinated paths. Scientists study these clusters to understand how black holes and stars coexist in the densest environments. Their quiet balance reveals the universe's ability to maintain order through calm, steady gravity. Some black holes influence how dark matter settles into the central regions of galaxies. Dark matter moves silently, forming smooth halos that shape the orbits of stars. The presence of a black hole helps refine this structure, guiding the inner halo into a more stable configuration. Thinking of dark matter flowing quietly around a black hole creates a soothing image, like invisible water settling into a calm basin. Scientists study these interactions using simulations to understand how galaxies maintain their shape over billions of years. The soft movement of dark matter adds an unseen but peaceful structure to cosmic environments. Some black holes sit inside galaxies with soft, diffuse jets that drift outward at slow speeds. These gentle jets look like faint beams of light stretching through darkness, moving far more slowly than the dramatic jets seen in active galaxies. Thinking of these slow jets feels calming, like watching thin streams of smoke rise from a candle. They carry energy outward in quiet, steady flows that help regulate the surrounding gas. Scientists observe these faint jets to understand how low-level black hole activity shapes galactic evolution. The serene motion of these soft streams reveals the quiet side of cosmic energy. Some black holes help produce gentle arcs of ultraviolet light as gas shifts in orbits near their centers. These arcs form when light reflects off gas, moving at smooth, predictable speeds. Thinking of these arcs feels peaceful, like glowing threads woven into the fabric of the galaxy. Scientists capture these arcs using specialized telescopes to study the temperature and motion of gas near the event horizon. The soft curves of ultraviolet light show how calmly the universe can behave even close to intense gravitational forces. As we drift back from the quiet edge of the universe, let your mind rest in the calm we've explored tonight. Black holes may sound mysterious and powerful, but when we look closely, they move with patience, balance, and a steady rhythm that echoes through space itself. If these gentle cosmic stories helped your thoughts slow down, let them stay with you as you settle into rest. The universe is wide, timeless, and soft at its edges, and there is always room for you to breathe within it. Thank you for spending these quiet moments here. When you're ready for another journey, another night sky, or another calm corner of the cosmos, come back, and we'll drift there together. For now, close your eyes, let go of the day, and float into a peaceful sleep. Good night and sweet dream.